The one other thing you have here is this little water pump. It's connected to the two Peltier systems we have on here for temperature control. One is the Peltier hood. I'll show you that here in just a second. Right here. When this is up, we'll install the Peltier hood around the top of the motor. And the other is the lower Peltier plate. Right? These are Peltier elements, real simple. I don't know if you're very familiar with them. Probably you've seen them in lots of things. But you know, two dissimilar metals attached to each other. You pass a current through the back one, change the sign of the current. The front heats or cools. This is the Peltier effect in a nutshell, right? But these two, the one principle for it to work very efficiently is that there can't be a very large delta in temperatures between the two plates. So let's say you're heating. You want to go to a high temperature, 50 degrees C or so. Not too significant, but you know, definitely warm. The backside plate is going to start getting very cold, right, as you change it. So what we do is we flush water over the back of it. Why? Because as it works to maintain 50 degrees in this environment, it's going to work harder and harder, and the backside might get colder and colder. We don't want this delta between the two plates to grow too large, right? Why? Because they're like light bulbs. They eventually burn out. It takes a lot. It might be hard to control that temperature point, the greater the delta gets between these two, to conduct the current across. So what this water is really just an equilibration, right? You have the front side, you're trying to go to really cold temperature. Front side, the Peltier is getting really cold, the back side is getting really warm, right? So when the back side gets really warm, we need something to carry the heat away. The water bath that we supply, fairly simple in this case. It's just a simple on device. You plug it in, it's on, right? So inside of here though, you'll notice we have water. The water needs to be at a level where it's just over the top here. In this case, it's a little low. There's not much water in there that I can see. So we should try to get some, here we have some distilled water. That should be good. You can use distilled, deionized water. If you use deionized water, this takes about a gallon, so you'd want like 3 quarts of deionized and 1 quart of tap water. Why? Deionized, when there's no ions in there, it can tax metal surfaces, stainless steel, and there's some throughout here. All I'm going to do is pour a little of this in. You can kind of see in there with that little grate, it's right over the top of it. And so now we've got enough water in there. You want to make sure the water's flowing. You can make sure the water's flowing by just pulling up. Reach in here, and there's that return line. And so if you feel water coming out of the return line, that's this one. See that? Yeah. You see the water coming out? Well, then you know it's flowing, right? Because it's being sucked up through the system. It's going through the hood, down through the base, back to the unit, right? So you know water's flowing. If you pull up that little return line and see it going through there. One other thing, water, obviously, will grow algae after a while.
Yeah.
These Peltier plates, the back of the plate that has the water being flushed over has channels, like between your fingers, right? If you get algae growing in here, it's probably growing in these little channels restricting flow.
Right.
This takes about a gallon, maybe a little more.
Okay.
20 drops per gallon of this. It's just algicide, it keeps the algae away.
Oh, I see. So, okay.
Recommend at least replacing this water once a month on use, and every time you replace it, put some algaecide in it.